So in this figure, we are given that AB is parallel to CD. See here, the line segment AB is parallel to the line segment CD. O is the midpoint of AD. See here, this point O is the midpoint of the line segment AD. So what do we understand from that? OA is equal to OD. Because O is the midpoint of AD, it means OA is equal to OD. With this given, we need to prove that triangle AOB is congruent to triangle DOC. Is congruent to this triangle DOC. Meaning, we need to prove that these two are identical triangles. When this triangle is placed over this triangle, they coincide. And we also have to prove that O is the midpoint of BC. O, see here, O is the midpoint of BC. We only know that O is the midpoint of AD. We have to prove that O is the midpoint of BC, which means we'll have to prove that OB is equal to OC. Alright. So, to prove these results, take up the two triangles given in this figure. Which are the two triangles? Triangle AOB and triangle COD. Take up the two triangles. Now, write out the pairs of equal angles or equal sides we see in these two triangles. But the information which you list out should satisfy one of the 5 congruence rules. So let's see the information we have here. I have marked these angles 1 and 2. Angle 1 of this triangle AOB is equal to angle 2 of triangle COD. Angle 1 of this triangle is equal to angle 2 of the other triangle. Why? Because they are vertically opposite angles and they are equal. What else we know? We know that OA is equal to OD because we are given that O is the midpoint of AD. So we have another information. OA is equal to OD. See, remember, angle 1 is of the first triangle. Angle 2 is of the second triangle. So you will have to list out pairs of equal angles or equal sides of these two triangles. So now see here again, we have OA of this triangle equal to OD of this triangle. OA is the side of this triangle. OD is the side of this triangle. And they are equal because it's given that O is the midpoint of AD. What else we have? We can also say that angle 3 is equal to angle 4. Angle 3 of this first triangle is equal to angle 4 of the second triangle. How do we know that? It's not given to us straight away. But since we know that these two are parallel lines, and when we regard AD as a transversal, alternate angles are equal. See here? Parallel line, transversal, parallel line. Alternate angles formed are equal. So 3 is equal to 4 because they form a pair of alternate interior angles. So what's the reason here? AB is parallel to CD and AD is a transversal. AD is a transversal. Alternate interior angles are equal. So now what have we listed? In these two triangles, we have listed one pair of equal sides and 2 pairs of equal angles. See here? 2 pairs of equal angles, 1 pair of equal sides. So then what is the rule we can use of the 5 rules? It has to be ASA. ASA because 2 angles and 1 side. It's about 2 angles and 1 side. And what is ASA? It is 2 angles and the included side. It cannot be any side. 2 angles and the included side. So which are the 2 angles here? See now in this triangle, in the first triangle, we have mentioned about angle 1 and angle 3. Angle 1 and angle 3. In the second triangle, we have mentioned about angle 2 and 4. Angle 2 and 4. So now which is the side included by the angles 1 and 3 in the first triangle? 1 and 3. OA. See here, the side included. Angle 1 and angle 3 are the angles mentioned in the first triangle. The included side is OA. And in the second triangle, we have mentioned about angle 2 and angle 4. Angle 2 and 4. Angle 2 and 4. Which is the included side? OD is the included side. And that's the information we have here. See here? OA. OA, which is the included side of the first triangle, is equal to OD, which is the included side of the second triangle. Included side meaning the side which is contained by the 2 angles. Angle 1 and angle 3 contain OA. Angle 2 and angle 4 contain OD. So clearly, by the ASA, 2 angles and included side, by the ASA congruence rule, these 2 triangles are congruent to each other. one very important thing is the order in which we name the triangles is very important. When you call the first triangle as AOB, you can do it in many ways, but let's understand one method first. So if you call this triangle AOB, this triangle is AOB. Now A is angle 3. Angle 3 goes with what? Angle 3 goes with 4. So when you say A in the first triangle, you must say D in the second triangle. And O. What is O in the first triangle? Angle 1. And angle 1 is equal to angle 2, which is again O in the second triangle. So when we say O here, we must say O here also, because this angle O goes with angle O here, meaning angle 1 goes with angle 2. And finally the third vertex B. So when you say AOB, we already finished DO, so the third vertex DOC. C is the third vertex. We've already written D and O, so the third vertex is C, DOC. The order in which we name the triangle is very, very important. So triangle AOB is congruent to triangle DOC by the ASA similarity criterion. So now that we have proved the two triangles are congruent to each other, their remaining corresponding parts are also equal. They are also congruent. That is what is CPCTC. Corresponding parts of congruent triangles are congruent. This can be used only after you prove that the triangles are congruent, not anywhere here. Once you show that the two triangles are congruent, their remaining corresponding angles and corresponding sides are also equal. So now how do we identify them? Now we need to prove that we proved that these two triangles are congruent to each other. We are done with that. We'll have to show that O is also the midpoint of BC. So to prove this, we use CPCTC. How do we use that? See here, now this order again is very important. AO, side AO goes with side DO. Side OB goes with OC. That's what we need. OB goes with OC. What's the other one? AB is equal to DC. AB. Now that we have proved the triangle is congruent, AB is equal to DC. I'll come again. AO is equal to DO. OB is equal to OC. And AB is equal to DC. But you just write what you need. Now these are the equal pairs of sides in the two triangles. But what do we need? We just need to show that OB is equal to OC. OB is equal to OC. So write out that OB is equal to OC, CPCTC. Why? Because we proved that the triangles are congruent to each other. So their corresponding sides are equal. OB is equal to OC, CPCTC. So this means O is the midpoint of BC.